Okay, well, today we are going to integrate functions. Now, what type of function can we integrate, and what are the different methods we can use to integrate a certain function? Now, first of all, here they talk about indefinite integral. Indefinite integral. Integral means you want to integrate something like this, right? Indefinite, that means there is no limit. Okay, we look at this one. Okay, now you have learned about this later on. You are going to learn about this. This type of integration, it has limit, upper limit and lower limit. So this type of integration is called definite integral. So this type where you have no upper limit or lower limit, then it is called indefinite integral. So when we talk about integration, then we say, oh, there are two types of integral: indefinite integral and definite integral. So indefinite integral is referring to this type of integration where there is no upper and lower limit. Definite integral, there's upper and lower limit. Okay, so we come back to this. So we are going to learn how to integrate a function. But before you integrate a function, you must know how to integrate term by term, like what we did in our differentiation. You must know how to differentiate one term by one term, then only we learn how to integrate a whole function. Okay, so we are going to learn how to integrate this one, x to the power of n. Then in front there's a number a there. Now this a is a constant and n can be any number but not -1. Now why not -1? I'm going to explain afterwards. So we integrate one term x to the power n, and this is the answer, then plus c. Now c is an arbitrary constant. Now it can be any number. Now if you remember earlier on here, right? I say that if you want to integrate 6x dx, then the answer is 3x squared plus c. So you see that earlier examples I've given you, it can be plus 5, it can be 3x minus 7, it can be 3x plus 5, and so on. So the number behind there, it can be any number. So we call it c. Okay. So now coming back to this indefinite integral, we have we want to integrate a single term like this, ax to the power n, right? How to integrate? Okay, ax to the power n, you know, a is a constant, is actually the coefficient of the term x to the power n. Then n here is a real number not equals to -1. Then this c is a arbitrary constant. So we look at one example. Now the first example, I want to integrate 5x squared. 5x squared, then the dx there means you have to integrate with respect to x. So integrate 5x squared with respect to x. So how to integrate this 5x squared? I'm going to tell you step by step, right? Now the 5 here, you don't integrate, you just leave it in front there. Just like when we do differentiation, when we differentiate, the number in front of the x term, you don't differentiate. So similarly, when you integrate 5x squared, the 5, which is a number, you don't integrate, you leave it in front. Then the x squared, you have to add 1 there to the index. X to the power of 2 become x to the power of 3. You just add 1. When you differentiate, you subtract 1. When you integrate, you add 1. Then you divide by this new number 3 there. This new number you put at the bottom there, 3. Then you plus c. Because when you integrate, there can be a number behind there. And that number we don't know. Right? We don't know. Okay, so this is how we're going to integrate. Now coming back to the formula here. So if you want to integrate ax to the power n, the number in front a, you don't integrate, you just leave it there. Then the index for x is n. So when you integrate, you add 1 there. So it becomes n plus 1. And you divide by the new number here, n plus 1. You divide by n plus 1 here. Then plus c. Okay, so this is how we're going to integrate one term involving x with respect to x. Any questions so far?
No, teacher.
No, we continue. Oh, I have another term here. 2 over 3x squared. 2 over 3x squared integrate with respect to x. Now the x squared is at the bottom. So actually the index is these guys. You don't know the actual index. So you change it to this form. Okay. 2 over 3x squared. The 2 over 3 is a number. So you can single out the number, separate the number. 2 over 3. You write here 2 over 3. You don't integrate. Then the x squared at the bottom, you bring to the top using your knowledge of indices. You bring the top, it becomes x to the power of -2. So you have to integrate 2 over 3, x to the power of -2 with respect to x. Now, so far what I have done is I just simplify the term. Okay, I didn't integrate yet. I did not integrate. So the integration sign is still here. Now, unless you have integrated, then this integration sign will disappear. Now, before you integrate, you just simplify, then the integration sign is still there. Okay, so now I proceed to integrate. 2 over 3 is a number, so you just leave it in front. Don't integrate. -2, when you add 1, becomes what? -2 plus 1 becomes -1. So here the index is -1. Then divide by the new number here, -1. You divide at the bottom. Then plus c. Now, have I integrated the function, the term x? Yes. So once you have changed the index here, when you have integrated, then the integration sign is no longer there. Now, why am I telling you this? When you have an integration sign, when you don't have an integration sign. Now, because when I mark the exercise book, I mark the exam papers, the students suka-suka they put integration sign there. Tidak suka there is no integration sign. They don't know when to put the integration sign, when not to put the integration sign. So now I have to tell you. Now, before you integrate, the integration sign is still there. From this step to this step, you just simplify. You did not integrate. So the integration sign is there. From this step to this step, you have integrated the x. So there is no more integration sign. Okay, next. Now, this negative sign you bring to the front becomes -2 over 3. Then x to the power of -1 is actually 1 over x. 1 over x. Okay. Then what is this? The 1 over x, the x multiplied with 3 becomes 3x. The 2 multiplied by 1 becomes 1. So the answer is -2 over 3x plus c. Then you may ask me, can you leave the answer like this? Can you leave the answer like this? Of course, I will tell you, this is the best form. You have to simplify it until the final form there, right? This form. Right? Any question?
Teacher,
Yes.
I don't understand the part that changed to 1 over x.
Okay. Now this one from here, right? So we start from here. After you have integrated the 2 over 3, there's a number here. You remember we gather all the numbers first. Numbers first, then followed by the terms involving x. Even when differentiate, we will pick up all the we multiply this number, multiply the very long number. So we pick up all the numbers first, then put it in front, then simplify the x. So the same thing we are going to do here. Now this is 2 over 3. Then at the bottom there's a -1 there. So 2 over 3 multiplied by -1. So what is it? -2 over 3. Okay, so this number multiply this number, you get -2 over 3. Then x to the power -1 is actually 1. With your knowledge of indices, x to the power negative 1 is actually 1 over x. Okay or not?
Okay, teacher, understand.
Okay, right. So, so this is how you're going to differentiate. The index, you plus 1, then you divide by the new index. Okay, not? That's very simple. So I don't want to show you plus 1, then equals to negative 1. I don't want to show like that. I just okay, now I summarize the type of questions that I've gone through with you. The first one is a very simple one. The x is a positive number. The second type, x is a negative number. Okay, when you simplify, x is a negative number. So I'm going to show you the third type. Oh, this one. You have to integrate square root. Okay, square root of. So you have to integrate the square root of x cubed. Okay, now square root of x cubed, you cannot integrate like that because you don't know what is the index. So from your knowledge of indices, you have to convert this into a term that has x to the power of something. So the 2 in front here, square root means there's a 2 in front. So the 2 goes to the bottom, the number goes to the top. So you have to integrate this x to the power of 3 over 2 with respect to x. So can you tell me what you have to do like that? If you want to integrate this term x to the power of 2 over 3. So what are you going to do? How? Jiayan can do or not? What must you do with the index here? 3 over 2, what must you do? What must you do?
Plus 1.
Yes, plus 1. So 3 over 2 plus 1 is 1. Okay, now this case I just show you because it's a fraction. So maybe it's a bit difficult for you to imagine. But next time you have to imagine already. I'm not going to write out for you. Okay or not? Okay, so next time I'm not going to write out. So 3 over 2 plus 1 is like that. 3 over 2 plus 1. So you are divide by the new index. This whole number here, you have to divide. Okay, right. 3 over 2 plus 1, do you know what it is? 5 over 2. So actually, you can skip this step. Straight away, you write down this one. Right. From here, 3 over 2 plus 1 is 5 over 2. When it's 5 over 2, you divide by 5 over 2. Then remember to plus c there, the arbitrary constant. For indefinite integral, you need to plus c. For definite integral, because there's the upper limit, lower limit, you don't have to plus c. Now later, I will explain to you why, right? But you remember indefinite integral, you have to plus c there. Okay, right. So how to simplify? Okay, divide by 5 over 2 is 2 over 5. The number is 2 over 5. So you have 2 over 5, x to the power of, this one don't change, 5 over 2. Okay, you want to put back in square root form. Okay, square root form. The number at the bottom here is the square root. The 5 here is x to the power of 5. Any question?
No, teacher.